Okay, measurements on equipment. So I'm gonna give a handout that has all of the various equipment you need to know. We're gonna obviously use a lot of this equipment in labs, but we don't use every single thing on the list just based off time. There will be hypothetical labs that we don't do, but you need to know how they work in order to answer questions about them. So I have a link to the list I'm going to give you. Here's a screenshot of it right here, but I'll give it right here. And so it lists the equipment and what it's used for. My biggest recommendation is some kind of flashcard, whether online like Quizlet or real life cards, and know the name of the equipment and know its uses. Knowing how it looks like, so you could see the picture right here, for example, would be handy, but not necessary. But it would be good to do. During class, I definitely will be asking random questions about this throughout the year. The FRQs assumes you'll know what the best equipment to use for different labs. So, for example, in general chemistry, you might have used beakers a lot, but flasks are usually used more for certain things. So, again, you have to know the uses. For ones that are similar-ish in terms of how they look like / function, there are ones that are better than others. So, for example, mixing stuff, usually a flask is better. But we will talk about which ones are better for different scenarios eventually. But for now, you should know the names of the equipment and what they are used for. Okay, so when you are measuring stuff, for example, on a graduated cylinder, you want to make sure you're looking at specific parts. So there is uncertainty in your measurements. It is a digit you estimate. And I'll talk about that with the example here. There are digits you know for sure when you are measuring on like a graduated cylinder or using any other equipment, but you need to make sure you also estimate. So here we have sig figs, right? If I wrote 49.0, that has 3 sig figs versus 49 is just 2. So the sig figs will matter for these particular problems. As a reminder, if you have an equipment where the water adheres to the sides like this, you go based off the meniscus, which is the lowest point of that curve when you are measuring. All right, so the stuff I just talked about on the previous slide, I'm going to use here. All of these are graduated cylinders, but anything that has lines for gradation and then being able to measure and count and stuff, the same skills apply. You always estimate the last digit, which again I'll talk about in a second. For this particular one, we're going to assume all of these are milliliters. If you have equipment in front of you, or if you have a word problem on an FRQ, for example, they will tell you what the measurement is. But for the purposes of this, because nothing is labeled here, we're just going to assume it's ml because most graduated cylinders are. So in this first one, I notice it's between 20 and 25, so that means each of these lines corresponds to 1. So it'd be 21, 22, 23, 24, and then 25. And so when I am writing what the answer is for this, you want to make sure that you write down the ones you know for sure first. So we know for sure, because again, each of these lines are 1, that we can know that it's going to be 21 for sure. Now, you see the meniscus, the curve down here. That's the one you're uncertain about. So therefore, you have to guesstimate what that is. I would guesstimate that's approximately the middle of that. So I would say it's 21.5 milliliters, give or take. Again, you want to make sure that you write down the numbers you know for sure, and then you have to guess one number afterwards. That is always the case. You always estimate whatever that last digit is. So make sure you do that for every measurement. Okay, Here we have a 6 to a 7, so that means we have this many lines. If I were to count, then therefore I know that each of these corresponds to 0.1. So I know this is 6, 6.1, 6.2, and so on. So I know for sure it's between 6 and 7, so I'm going to do that. I know for sure that it at least is touching that line here, so that corresponds to the 6, and then I have to guess that last digit. And so in this case, I could guess it's probably just touching that line, so I would say 6.60. If that line was slightly above, then you can guess 6.61 or so on. Again, you are estimating that last digit. This graduated cylinder over here, it's between 30 and 40. So if I were to show the other part, each of these would be a 1. If you notice, the bigger line usually corresponds to the halfway mark. If there is one like this one doesn't, but this one has it. So that means each of these are a 1. So I know for sure it's going to be 3. And then I know this is 5 and that's 6. It looks like it's probably touching that line, so it's 31, and then my estimated value would be 0 because I know these lines measure in the ones place, so you want to go 1 afterwards. Here we have 80 to 90, so we know each of these lines are going to correspond to the ones place, so I'm going to go ahead and write 8. And then here you can see the meniscus is like kind of here-ish, give or take, and so I can count 80, 81, 82. And then here's where you estimate that line in the middle. I think it's slightly above half, so I'm going to say maybe like 82.6. Don't forget your units. So these are all milliliters, so make sure that you have them. And so you can't see behind me, but this is 82.6. All right, so these are all graduated cylinders. Make sure to look at the gradation lines and then see if you can figure these out. And then don't forget your unit. So go ahead and pause this video. All right, ready? Here we go. So we know that this is in between 6 and 7. We know that each of these lines will correspond to the tenths place, so I know those 2 digits for sure. So I could see it is 1, 2, 3, so that's going to be 6.3. And then I see the curve is not half, it's barely above the 3. So again, this is uncertain. You can have any number here, depends on, what makes kind of sense, because again, this is guesstimate. I'm going to guesstimate it to be a 2. You could have guesstimated it to be a 3 or a 1, whatever. Cool. All right. Next one, we have 40 to 50, so that means each of these lines is going to be a 1. So I know for sure this is going to be 44. So 44. And then again, you estimate this last digit. I'm going to say it's probably an 8, I guess. So 44.8 milliliters. And then the last one here, you can look down here just because the box zoomed in, it's kind of cutting off the lines. You could see this is between 5 and 10, so therefore each of these lines have to correspond to 1. So that means this right here is going to go ahead and be 21, and then you have to estimate that last point. So you can estimate that to be like a 5 or a 6 or whatever, and then don't forget your unit. So pretty much it's 21.5 milliliters. All right, so that is honestly it for this section. We're gonna continually be measuring stuff with different scientific equipment, so just make sure that if it's something that you have to look at, like gradation lines or something, you know your certain digits, and then you don't know your other ones, so you measure, an approximate or estimated digit. All right, see you on the next one. Bye!